Hi everybody, welcome back to the Feynman technique. Today we are going to be solving this integral right here. It looks pretty crazy, and it is. Again, this is another integral I got off the channel Maths 505, and we're going to be solving it step by step using Feynman's technique. Okay, so how are we going to start? Oh, and by the way, I just put in some random parameters for A and B. This is just for checking that we still have the same result when we get done. All right, so right away I'm going to reparameterize. Now, I could just consider this a parameter of either A or B already, but I like using f of t. So we're going to say that f of t is equal to, let's see, let's just make it the integral from 0 to infinity of natural log of 1 plus x to the t times 1 over 1 plus x squared natural log x dx. Okay, well, that's not really good. It looks like that only converges at one point. So, I'm not going to use that. Let's go ahead and actually have our f of t be natural log of 1 plus x to the t over 1 plus x to the b. All right. Oh, well that definitely converges. Okay. So we're going to use that because when we take the derivative with respect to t, this whole part is going to drop out using the properties of logarithms. We'll get the natural log of this times this minus the natural log of this times this. And the natural log of this times this has no t's in it. So with respect to t, it just goes away. So let's see. What are we going to get? Well, first, let's note that f of a is going to give us I, right? That's going to give us back our original integral. And also f at 0 will give, I'm sorry, f at b will give us 0 because we'll end up with, this will become a b and we'll have 1 plus x to the b upstairs and downstairs in our natural log. That's just going to become a natural log 1, which would go to 0. So we can say f of b is equal to 0. All right. Okay, so now what? Well, we'll use the standard Feynman's integration trick of differentiating our function of t with respect to t. So what's that going to give us? Well, we'll still have the integral from 0 to infinity. Let me scroll down a little bit. We're still going to have this term, and we're going to get 1 over this term. So we'll put a 1 plus x to the t, then times the derivative with respect to t of x to the t. That's going to give us x to the t times a natural log x, which will cancel this. So there is our f prime of t. And it looks like f prime of t is constant at pi over 4, but we're going to have to show that. We can't just say that f prime of t is equal to pi over 4 right now and say we're done. We have to show that that's equal to pi over 4. All right, so what I would like to do, gosh, how are we going to solve that? Okay, okay, I know a trick here. So we're going to let u equal 1 over x. That's going to imply that, well, x is equal to 1 over u, which also implies that dx is equal to negative 1 over u squared du. So let's go ahead and make that substitution. All right, u is 1 over infinity, that's 0. 1 over 0 is infinity. We're going to get u to the negative t here. This will become a u to the negative t. This will become a u to the negative 2. And we'll go ahead and put a parentheses here. This is going to become a du. And we will have, negative 1 over u squared there. All right. Now, let's use this negative sign to switch our bounds of integration. Let's distribute this u squared into here. So we're going to have u to the negative 2 times u squared and 1 times u squared. So we have u to the 2 minus 2. That's u to the 0. That is 1. And then let's multiply upstairs and downstairs by u to the t. That's going to give us 1 here. If we multiply by u to the t, we'll get a u to the t here and a 1 here. So now we have two different expressions, very useful expressions for f prime of t. So now we can say, we can add this version and this version together to give us 2 f prime of t is going to be equal to this. After you switch the dummy variable back to x here, you'll just get this. And then you'll see that this x to the t plus 1 upstairs and downstairs cancels out. And we know for sure that this integral right here is pi over 2. And we know for sure, well, so now we have f prime of t is just equal to pi over 4. Okay, well, all right, great. We have f prime of t, but we want f of t. So f of t is equal to the antiderivative of pi over 4 with respect to t. That's going to give us pi t over 4 plus c. And now we can use f of b equaling 0 to find c. So f of b equals 0, and that also equals pi b over 4 plus c. So that means that c is equal to negative pi b over 4. So we can go ahead and plug that in. So there's our f of t, and furthermore, we know that f at a is equal to our original integral. F at a is equal to I, but that's also equal to this, where t is equal to a. So we can finally say that I is equal to pi over 4 times quantity a minus b. And let's drag this up here and make sure that does indeed equal our original integral for all values of a and b. Let's go ahead and, yeah. Okay, let's change this to a negative number, perhaps. There we go. Yep, that works. It all works. All right, guys, so that's how you do it. The integral from 0 to infinity of this crap right here is just pi over 4 times quantity a minus b. I hope you enjoyed that, and we'll see you next time.